All right, so explaining the bar, what the bar length does, and how all the settings function here. All right, let's connect that up. All right, so the bar length solver, another basic solver here, and as the name implies, it's designed to look for bars of a certain length. So you could use it. So you can use the bar length solver to look for bars, with a long length. Yeah, the names are kind of backwards here, but you could find bars of a minimum size or find bars of a maximum size. So here the names look like they're backwards here, but down in the output it says at or above, really, or at or greater, than 1 ATR, or you could find bars that are essentially less than 1 ATR, right? So that's what this solver is for. Is it helps you find really, bars of a minimum length or bars of a maximum length there. And let's switch back to minute charts, and let's kind of clean things up there. All right, so let's start with the default settings here, right? So it's set up to identify bars that have a length of at or greater or above 1 ATR, right? So all these little short bars, right, don't have a signal. There is an output, right? So you can see that this is functioning using the fuzzy logic capability of BloodHound, right? And we'll circle back around to this, but really, the default setting is to identify bars of 1 ATR or greater, and because it's set to the fuzzy logic, it's actually finding bars of 0.8 ATRs because of the way this kind of goes back to BloodHound's more basic calculation, which is using, what's considered a signal, right? And what's considered a signal is a value of 0.8 or more, right? Again, this is going back to using the fuzzy logic capability, right? So those lines there, right, that green line is 0.8 and the red line is 0.8, right? So that means 80% of the output is considered a signal, right? So when this output reaches 80% confidence, it's considered a signal. So I'm not going to dive deep into the fuzzy logic with this, all right? But that is the default setting here. So if we wanted to strip out that fuzzy logic, what we need to do is set the minimum length here. And if we just set it to 0.9, right, which is just under 1, there we go. It almost completely strips out the fuzzy logic. We can see there's still a little bit of fuzzy logic left in it. I guess, mainly because, these NQ bars are so long that, that you can still get a little fuzzy logic there. So if you really wanted to strip it out, you could go 0.99 there. All right. So 0.99 to 1 ATR. There you go. The fuzzy logic is now completely stripped out. And so all of these bars here that have a signal or an output on them are at least 1 ATR or greater in size, right? So there you go. So the output says at or above 1 ATR. So now let's say we wanted to find bars that were less than 1 ATR. Then we could just change the output, put a 0 in there and put a 1 there, right? And so now we're identifying bars that are at 0.99 ATRs or less or below, right? So there we go. Yeah, so most of these bars are less than 1 ATR. Now, of course, with the measurement unit, there's other choices here. So you could either say, use points, so you could find bars of a minimum point size or point size, or you could use ticks, and then there's Renko bricks, which really nobody uses, and there's a separate video that explains that, and then there's ATRs. So I think at some point we're probably going to remove the Renko bricks because nobody uses it. Yeah, and it's kind of difficult to understand. So, so this 3 standard ways of measuring a bar length is points, ticks, or ATRs. Right? And that really, is the core of all the bar length does. Now there's some other settings here. Let's see, let's put this back to normal, like so. There. So you can also look at an average, so we could say, okay, I want to identify 2 bars that are at least 1 ATR in length. But that's an average. So if we take the average of the last 2 bars, the average of the last 2 bars, 1 ATR or more. And let's see here. So, yeah, interesting. So here, right, so we can see we had a bunch of bars, kind of small, and then we get this long bar, right? Then we get to this really long bar, right? So obviously this really long bar is longer than the average, right? So it's no surprise that this long bar, has an output on it. And this next bar, yes, that definitely looks a little longer than the average here. So this bar as well. But then we get to this bar, right? Which actually looks longer than the previous bar. So why doesn't it have an output? Well, probably because this long bar skewed the ATR calculation. And this bar back here, I'm pretty sure is within, let's see, what is our ATR period? Oh, okay. Well, the ATR period is set to 100. Yeah. So it, that's going to be hard to figure out exactly, what the formula is, but just generally speaking here, we had this long bar and we had another long bar, so those 2 bars, looking back on 100 period setting, is going to increase the ATR value ever so slightly. And so eventually when we got to this guy, the ATR kept rising and rising and rising. You could put the ATR indicator on the chart, and verify all that, but eventually the ATR kept increasing until this longer bar was less than 1 ATR, and then you get to this bar, which is like a couple of ticks, actually maybe a couple of points. Yeah, these bars are really long on the NQ today, but in any case, this bar is longer than the previous one. So even though the ATR was continuing to rise, the average of these last 2 bars there, this bar did exceed the 1 ATR over the average. So now you could say, all right, show me, the smallest. And of course, when that happens, let's see here. Let me pull this back. So what this is doing is this is looking at the smallest of the last two bars and saying, is the shorter of the last two bars 1 ATR or larger? Right. And so let's look at this guy. All right. So looking at the last two bars, right, the current bar and the last bar, is the shorter one, which this is the shorter one, is it 1 ATR or larger? And it's not. Okay. We can knock this down. We can set this back to 1. And so when the period is set to 1, the mode actually doesn't do anything, right? Because you're only looking at a single bar. So you can't find the smallest out of X number of bars. You can't average, right? Because an average of 1 is always 1, right? And you can't find the largest. So the mode really has no effect when your period is set to 1, because you're only looking at that one individual bar there. So we can see that, yes, this bar actually, out of these two bars, the smaller one is less than 1 ATR. Right? So let's change the period back to 2. And so now if we step forward, so now we're looking at these two bars. Right? So is the smallest there 1 ATR? And that's the smaller one. And there you go. So actually both of these bars were 1 ATR in size or larger. Okay, so let's look at those two. Let's knock that down to 1. Wait for it to update. And there we go. Actually, both of those bars were 1 ATR in size. So the smaller one was definitely 1 ATR, right? So you could, so out of, the last X number of bars, so we could, whatever it is, 3, basically you're saying, look at the smallest of the last 3 bars, and is it 1 ATR in size? So here, right, so within these 3 bars, this one was less than 1 ATR. Right? So it didn't count. And of course, when we get to the next one, well, we already know that, oh, come on, Ninja. All right, hang tight. Man. All right, back to where I was at. So we already know that this bar is a pretty large bar, right? So it's more than 1 ATR. We already found out that's more than 1 ATR, and clearly that bar, it's pretty long as well. So all 3 of these bars, even the shortest one, which would be that one, is more than 1 ATR, right? And then of course, as far as the largest, right, that's looking at the largest bar and seeing, is the largest bar at least 1 ATR or more. So yeah, let's look at this here, for example, right? So this would be the largest bar of these 3 bars. So yeah, that largest bar is at least 1 ATR. Maybe even that one might be 1 ATR, right? Let's go forward, another one. So yep, that's the largest right there of these last 3 bars. Oh wait, hold on. So no, yeah, that's the largest bar, but that's not 1 ATR. So therefore, on the current bar, there's no output, right? So when this bar closed, look back at the last 3 bars, find the largest one. That was not 1 ATR. This might be, no, actually this bar looks a little larger than that one. So, but again, this is the largest bar of the last 3, and it's not 1 ATR. So that's what it's telling you. And then we step forward to this one. This one definitely looks like it's 1 ATR. So it's a lot larger there out of the last 3 bars. So yes, so this mode here is pretty straightforward there. Identify either the smallest bar out of the last X number of bars here, whatever it is, and is it larger, or, well, actually what this mode is identifying is more specifically what the output is identifying. So since our output is looking for bars of a minimum size, then smallest, average, and largest, right? It's of X number of bars. So this mode is actually working for the output that we're looking for. So it's actually looking for bars of 1 ATR or larger. Right? And of course, if we reversed the output, so to speak, right? So if we're looking for small bars, now the largest would be looking at the largest bar, and is the largest bar less than 1 ATR, right? Or is the smallest bar out of the last 5 bars less than 1 ATR? And as we kind of know, most of these bars are less than 1 ATR. So it's no surprise that we're getting a really large output. And right here, yeah, we can see, right, we just got a big move, so we got a lot of big bars here. And so we do actually have this, couple of bars where the smallest of the last 5, right, the smallest of the last 5 is actually less than 1 ATRs. So, there. All right, that does it for the bar length. Let's see. Yeah, I guess I'll go ahead and throw in the modifiers here, right? So enable, pretty straightforward. We could temporarily disable that solver, and there we go. Now there's no output, right? Because that solver is disabled, right? Now we can invert this, right? And I guess, let me note here that, right, bar length is a non-directional condition, right? The length of the bar doesn't tell you if you should be trading long or short, right? It's non-directional. So the bar length will always give you a long output and a short output, right? unless you use the evaluate here, but we'll get to that in a minute. Right? So if you invert this, right, pay attention right here where there's no output, right? If we invert that, there we go. So it inverted it. So where there was an output, there is now no output, and when there was no output, now there is an output. Right? So that's invert. Now swap is not going to do anything because the long output and the short output, they're both on at the same time. So if I hit swap, that's not going to do anything for the bar length solver, right? Because of the way it always gives you a long and short output there. So right. Now, if for some reason with the bar length you only want a long or a short output, you can use the evaluate. But really, that really doesn't, for practical purposes, of building a trading system, again, bar length is non-directional. So I doubt anybody would ever need to use this with the bar length, but you could take it and produce a long output only from it, right? Now, if we swap that, there we go. So now the long output was swapped to a short output. So only if you're, using the evaluate would the swap do anything, but why would you use them both together, right? It really doesn't make sense. If you wanted a short output, well, then just use the short only. There you go, right? So, yeah. So, in practical terms, you're really never going to use the evaluate with the bar length, but you might use the invert. So maybe you set the bar length up and you're like, oh man, everything's completely the opposite of what I wanted, right? And you're a little confused. Okay, how do I adjust everything to get the opposite result? Well, you don't have to do that. You could just hit the invert and there you go. Now we got the opposite result there of what you're looking for. So that's where the invert really kind of comes in handy, is you're building something and you realize, oh, I need the complete opposite, and you can just invert it instead of trying to reverse all the settings there.